Welcome to the lecture series on object oriented analysis and design. In the last lecture, we have been talking about knowing object oriented for what purpose? For the purpose of understanding people productivity. Productivity remains a big paradox in the field of IT. It is not something like a machinizable work where if I can produce one brick in half an hour, how many bricks can be produced in 8 hours? 16 bricks. Quick answer. We are not able to do that. We cannot produce one line of software every 5 minutes or 10 minutes or 1 hour. So, we have had some nice data that has been collected, and there is good agencies like Capers Jones that have said that if you claim that you are proficient in C programming language, in an 8-hour working day you should produce 60 LOC lines of code. Again, lines of code is a very crude metric. Roughly it means that you are expected to produce something like 7 lines every 1 hour without fail. So, which means if I take stock of the work being done by a programmer every hour, each time I visit there must be 7 different lines of code shown to the person who is visiting, or as a quality assurance fellow if I visit. Programming has never been like that. For days together we may not get an idea. We may be only simply thinking which statement can be put in what position to make sure that our well defined input is transformed into the well defined output exactly like that. One more concern that we have been having, because if you start looking at the entire exercise as well defined input to well defined output, we will always get bogged down. When we are getting stuck, we are getting stuck for a longer duration in this way of looking at what we are attempting to do, because we won't know where else it will hit. It is not such an easy exercise. So, the idea of componentization object is nice, because it will tell us very quickly that you do this, this will be done, this much will be assured. You build based on whatever you have done. A good idea which increases the people productivity, because in the earlier method, while we have learnt wonderful lessons in the earlier method, we get stuck for a longer time whenever we are getting stuck. We can't do anything about it, because we have to get a full idea, we have to get an understanding as to what is the import of one line being put here. Because of all these reasons, once again we keep telling that if somebody else has written the code, and if you are expected to change about 10% of the code, please throw away the entire code, start from the scratch, redo the exercise. That will be more efficient. Whereas here in object oriented we are talking about reusability. It does not matter to me who developed the code. If it has been nicely componentized in conformance with our object oriented, I can simply pick it and use it. The granularity and the grade of reuse, the percentage of reuse, those remain challenges. Even today they are challenges, plenty of challenges. The paradigm has been very promising on these accounts. Now, the concern here is that in the context of IT, productivity has never been so straight. It can never be also. So, in theory, yes, on an average 8 hours working day, 60 LOC should be produced by anyone who claims proficiency in C language. Well, then we started talking about what is the case with other languages. If C language it is 60 LOC, C++ how much? Well, again we are talking about the same story. We cannot equate this LOC to one object that is produced on an assembly line, which will be multiplied. LOC is not simply multiplying, each line is a different line. It is not that 1 brick, 2 bricks, 3 bricks, 1 pen, 2 pen, 3 pen, each line is a different line, each line expects creativity, and therefore our way of problem solving and expression have to be understood in a different perspective. That is what we mean by people productivity, not a machinized way of telling that alright, with this kind of a method we are able to produce 16 bricks in 8-hour working day. how will I make it 24 bricks? Theoretically, it is a good question. Can I have 2 more people? Again a good question. The way in which we have been talking about work and time, these were some nice problems. Every high school mathematics text would have some such problems, work and time. Those problems are very nice. If this can be done in 3 hours, how long will you take to do this much of a work? Our idea of work breakdown structure, everything needs a clear understanding of what is the paradigm, the entire paradigm going to do. It is not to be done in a bitwise or a piecemeal manner. The entire paradigm, when it is used, will assure people productivity with problem solving as a keynote, ease of expression, ease of debugging, ease of verification and validation, prevention of errors while expression, extensibility and maintainability, talk about compilers, talk about optimizing compilers, talk about intelligent compilers, talk about development paradigms. Anything we talk about it, it is the case of understanding that the way we talk about productivity is paradoxical many times, because we dream about a solution most of the times. We don't even know the technology will come. The entire methodology is like that. Essential requirements are different than other requirements which go into the design bucket. Technology is the first thing that goes into the design bucket. Essential requirements will be first, independent of the technology. We want to talk about what are those requirements. So what did we do now? We said that requirements is like this, and it is the biggest villain, because in software engineering 70% of the requirements change as we progress. Maybe next day it will be changed, because what we are promising in software engineering is it's perfectly elastic, perfectly plastic, everything can be changed, nothing is cast in stone. So as we progress, we will understand how these essential requirements will become critical, and therefore we have been trying to position software engineering as something which is like this, and in this method, using whatever paradigms we did, at the grade of complexity we want to work so that there is a good return on investment, we have been able to show a success rate of 36%. It is not that we have to compare apples and oranges, but then compared to other established engineering disciplines, in just 60 years we reached this position. The challenges are still ahead. So problem solving we understand, managing complexity, what did we do? We are not able to get a single programming paradigm that will take care of everything under the sun. So different programming paradigms have been positioned, and we talked about object oriented programming paradigm in this particular series of lectures. And what we understand is that it is not to exclude other programming paradigms, it is not even to tell that it is very unique, it does not have anything in common with other programming paradigms, but it is nicely put together in a manner where we can benefit from the higher order concepts like polymorphism, data encapsulation, inheritance, state, behavior, communication, reusability. So these are certain higher order ideas which we can talk about, and this paradigm called object oriented paradigm is pushing us through all these to ensure so many things we have been talking about as people productivity. When we talk people first, what we are talking about are people productivity. So these many things we will assure, provided you talk about this paradigm in its own way. I must also mention that because of the commonalities across programming paradigms, and because we started from the same base, we have gone together for quite some time, nearly 4 decades. So we understand that there is always a temptation to use something as some other idea. Well, for quite many years, mixed language programming was not permitted at the language level, later on at the paradigm level. We cannot mix paradigms at all. If you have chosen this paradigm, you are true to this paradigm. It has given you some advantages, it has its flip side, but that is just about what we acknowledge. Everything is like that. These are the advantages, these are disadvantages. How to leverage the paradigm to make best use of the advantages which it is offering is a challenge which we have been facing as people involved at stakeholder level, domain expertise level, problem finder level, solver level, developer level, at all levels. So, what we have found therefore is a very simple point, that we should not mix paradigms, we should not mix languages. However, we are all aware that let us look at the structured programming language called Fortran. It has great libraries for mathematical functions. Till today, we have not come across any other library set of library routines that have so much wonderful depth in mathematical functions. Everything that you want to do in mathematics should be already there in Fortran. That was our gut reaction. We learnt only one language in BE, that was Fortran 4, that was 85. So, we know for sure that whatever you want to do in mathematics, it is like that. It has great libraries. No other language in structured programming world, or even object or any other paradigm, will give you that assurance that these are all very well written, efficient, absolutely tested set of library routines. Close your eyes and call tan hyperbole, it will work. Close your eyes and say tan inverse, it will work. But then these libraries are only with Fortran. What will the poor C programmer do who wants to do the mathematical equations? Will he reinvent the wheel? Will he or she keep redoing the same thing? It has Fortran 4 has established over nearly 2 decades of wonderful research in scientific development, space, atomic. So many things have happened. So, are we going to reinvent the wheel? These were the concerns. So, what we thought was, if at all we have a way of calling it some package, call that some package, it is there, it can be linked by any language construct that can make use of that package. One more idea outside of reusability, some are packages. You can simply link them to the package can be linked to your code and you can start working. So, we have been talking about language independence, we have been talking about platform independence. Now, all these ideas are reasonably advanced, and we strongly believe that these will be greater productivity enhancers because the functionalities are almost there. So, today we have come to a stage where object oriented analysis and design, if that is done up to the design bucket, you are comfortable, you are confident, and you are saying that we can go ahead. It is only a matter of a press button, code generator will happen. The code generator will take care of all the nuances. If you tell that there is a package that is available here like that, it can just go and link it up. So, language independence, platform independence, in summary, at all levels we want to ensure what is called interoperability. So, this much we know about OO, but how do we work with it? So, that is the subject matter which we are moving into right now. How do we work with this? The concepts are all good. We have spoken about classification theory, we have talked about classes, we talked about objects, we spoke about so many things about objects, conflicts, but how do we work with this? This is the way we work with it. A typical object oriented programming system will start finding out if we can think of objects, thinking in objects. As I said, it is a completely different way of thinking. What is the beginning of that different way of thinking? Classification. Once again, I am not talking only about tangible objects. As we progress in this set of lectures, we will know that most of the times software engineers talk about abstract objects, some things which we can define anything. Well, in theory you can always keep quipping that it is like a lion head, giraffe body, snake tail. A part of it appears to be a fan, a part of it appears to be a light, a part of it appears to be a chair. Such kind of an object I will never see. There is no way in which I can see that kind of an object in real life to solve my real life problems. But then the world of object oriented, the world of software engineering is replete with abstract objects. It is lot more simpler to drive home all these ideas based on tangible objects. Even tangible object identification and modeling is a big challenge that we have seen in earlier lectures. The intangible or the abstract objects are going to be even more difficult to get. So, we have been talking about so many things. Even today, the latest controversy about face recognition, we can put faces. How will you know? Somebody is resembling somebody else, somebody is mocking somebody else. So, there is no end to all these things. There are so many things. Today also we are talking about objectifying, trying to understand a face, trying to fit it amongst various other things. So, we started talking about class, a class of people. We always keep telling that there will always exist 8 people who look similar. In a given space, in a given domain, in a quick time, we can always tell that there will exist 8 people who are looking similar. One way of telling is we get more advanced technologies, we get more recognition, more identification systems. So, what we have therefore been telling is, by definition, an object has a state, a behavior and an identity. Only when we talk about the class, we tell that the identity of a given object is not so serious, but we are talking about those aspects which are common to all. All people are going to a movie, that is a common method, whereas the people are individuals. So, when we talk about class, we are leaving out the identity of an object intact, and that is a bit tricky, that is a bit slippery also, because we have to move to the higher end called inheritance. When we move one more layer, we will now once again subsume the identity. The way we build software is like that. Where is the identity? Clear at the object level. On top of it, we have a layer called class. On top of it, we will create the concept called inheritance, polymorphism, abstraction, finally encapsulation. So, by definition in this exercise, the identity of an object is something that is found only at the bottom up level. As you come lower and lower and lower, you find the particular identity. A typical example, what happened last year, we purchased something called 50 Wi-Fi mouses. Where are they? Simple question. It is not about an inventory, it is not about location, but how do you solve that problem? All are from the same manufacturer, same brand. 50 Wi-Fi mouses have been purchased. Where is one particular mouse? You have to locate. That has an identity, but the top level you will not have the identity. If you have 50, you have 50, if you have 48, you write off 2, whichever is your procedure. So, what has happened in our way of analysis and design is that if we bank more on the top down, we are completely forgetting those objects which we have made and kept it. So many artifacts are there which have been made and nobody knows how to track them. We do not even know that it has been made. We will completely forget that notion of identity is at the start, is the first step, and therefore, what we said was we have to do top down analysis, but we cannot simply be locked into the top down analysis. Our construction is best when we are talking bottom up, because we see the identities clearly, we build them better. A class is there, an inheritance is there, polymorphism, all these ideas which we have been talking about. Abstraction till today remains the number one strength in answering or addressing complexity in every domain, every human endeavor. The more you abstract, the stronger you are in terms of facing complexity, even if it multiplies all of a sudden. So, this is where we bank on, and then we said data encapsulation, because you need not know anything about it. You can simply start here. What is it that you want to do? If it is permissible to know, you please go ahead and use it right from here. All these inner details are completely hidden. You need not know, they need not tell. So, that is a granularity which object oriented programming system promises. Say that this is what is there, you please go ahead and use it, fully encapsulated. Once you get to this point, it will do the thing for you. This we have tested, done everything. Object oriented software engineering has done it. So, the first concept, data encapsulation. All this is happening properly, and we will start here the bottom up construction. This is all internalized, only this is known, and what is coming in, what is going out. The state of this encapsulated entity is so clear from what is coming in and what is going out. If this is coming in and this is going out, we can always figure out what is exactly happening here. We need not know the internal details. I need not know the internal details of each and every library routine of Fortran mathematical function, provided they are from a standard organization, they are packaged by a standard organization, and I trust that organization. I simply go ahead and link it to my program, it will work. It's fully encapsulated. So, encapsulation itself is a bigger complexity. So, the point is, object oriented programming or object oriented analysis does not pay off straight away until you are looking at a reasonable complexity. We keep saying roughly around 1 lakh LOC. So, if all that is assured, I will close my eyes and link to the package, include the package, and then go ahead. The package is included. C++ constructs are very well known, and then just go ahead, use that, it will work. I go ahead with the value which tan hyperbole gives me, I go ahead with the value which tan inverse gives me, and that is just about it. So, we have been talking about a bigger picture, something like at the package level. It works, it will identify, it will do everything on its own and gives you the answer. That is all you are needing. And the machines have become faster. There is no concern about the memory. You can keep all the packages up. Machines have become much faster. So, therefore, at this granularity, we see everything. Productivity is there because I don't rewrite. Now, the big question comes, if you have to use only tan inverse, why should I link the entire package? Well, that's up to you. It's up to you. If you want to write, you write. If you want to spend time, it is up to the programmer to decide. It's a system where you decide whether for only tan inverse will I use the entire encapsulated library. That is a question which we will answer later. So, essentially we have been talking about polymorphism, encapsulation, abstraction, inheritance. First slide now is polymorphism. At the compile time, you can tell which data item is what. It can have a function name overloading, it can have an operator overloading, at runtime it can be a virtual function. So, polymorphism essentially says that when a function call has happened, based on the parameters passed, the object can take a decision on the type of the data with which it is working. So, there are two function overloading, operator overloading that can be done at the compile time. The compile time compiler will tell, at runtime we have a virtual function. The next one is inheritance. This is something which has been a very special idea in object oriented programming, object oriented analysis and design. Single inheritance, a subclass derives from a single superclass. Multiple inheritance, a subclass derives from more than one superclass. Multiple level inheritance, a subclass derives from a superclass which in turn derived from another class. There is one more, 3 layers. One superclass, subclass, subclass, multi-level inheritance. Hierarchical inheritance, a class has a number of subclasses, each of which may have subsequent subclasses continuing for a number of levels so as to form a tree structure. Now, in all these things, the data encapsulation will ensure that you will hit the correct object instance. There is no second opinion which has identity. Hybrid inheritance, a combination of multiple and multi-level inheritance so as to form a lattice structure. These are some good examples. Single inheritance, student having scholarship. Everything about the student remains the same in the subclass except that one parameter called scholarship. That is the difference. Multiple inheritance, there is a wheel, there is a rubber, and both of them will make a tire. Many number of wheels can be there, many number of rubber types can be there, both of them are necessary. It inherits from the type of the wheel, it inherits from the type of the rubber. Both are necessary to make multiple inheritance. So, please understand that in theory we can make different types of wheels, different types of rubbers, but then in the market we make sure that we will get only this particular specification of the wheel, this particular specification of the tire. You cannot get anything that you want, even though in theory you can make. I can make 6 feet diameter tire, 6 feet diameter axle, wheel. I can make 60 feet diameter tire and 60 feet diameter wheel. Why not? They can fit. So, therefore, what is it that we are talking about is in pragmatics of the way we work, we build, we engineer things, we need to have certain standard specifications, and based on those standards it becomes very seamless. So, a part of this exercise which I am trying to drive home will be standards. Are there any standards? Remember, if we did not have the standards, we would have been specifying every tube light separately, every tube light holder separately, every choke separately, every starter separately, every switch separately, every wire separately, everything would be separate. Because we have standards, because we are very confident that the electrical supply here is 50 hertz, 50 cycles per second, we are very confident that all of them work well. Suddenly, if some apparatus comes which has to work on 60 hertz, which is true in many other countries, we need an adapter. Only at that time we will realize that there is need for an adapter. So, fortunately in our university we have plenty of international conferences running. Somewhere we will get the adapter. We will have the adapter. It will be stocked. It is just that we have to locate. Each time people come from various countries, they need this adapter. Even to charge the mobile phone, you need an adapter. So, this is how we have been talking about. Please look, we will go back one slide, and to summarize, the specialities polymorphism, data encapsulation and inheritance are so nice in object oriented that we talk about these three as the most dominant ideas. Inheritance particularly is very special: single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, hybrid inheritance. Thank you. We will meet in the next class.